Evening, everyone. Hope you're all well. COVID-free, at least for today. Popular topic coming from Sydney. Discussed this months ago, but I digress. So, VoltServer, not PoE. Not PoE. The remote powering allows you to deliver power to the PoE device by away. That's the best way to think of it. Okay. So, what is it? It's actually a server-based that sits in a rack in a head that you can input either AC or DC power. What it does is that power has similar packet of data down a cable, and that power up to 2 kilowatts, and it can travel up to kilometers. Okay. Yeah, no problem. And if it gets too heavily technical, the discussions for the Q&A, then I'll refer it to later on. Otherwise, we'll be here all night, and we want to get to the tavern, right? So, so basically, you have a transmitter that you plug into a power source. That power source could be a UPS, it could be a solar panel, it could be the AC outlet on the wall, and you have a twisted pair cable. Now, to deliver 2,000 watts down 2 kilometers, you need approximately a 3.5 cable. Now, it's not a standard instrumentation cable. You have to worry about the capacitance between pairs and between the shield. So it's got to meet periods. But to deliver that high load over a long distance, a very short cable, can actually deliver power down. I won't get 2,000 watts over 2 kilometers over a Cat6A cable. There is a derating scheme. There is a fairly extensive chart to show you what conductor size, how many pairs that you need to deliver a certain amount of watts over a certain. So you're probably talking, 500 watts over maybe 300 meters, depending on the conductor size, because not all Cat6 cables have the same conductor size. So that does play a part. Now, the thing about this system, and it's not PoE, it does actually send a packet of data down with the electricity. And that packet of data is a safety mechanism. So it sends that data down, and if it's not received at the other end, it actually shuts the system down. So it's safe for human touch. So it's actually classified as ES2 compliant. Now, we know voltages over power over 90 sort of watts is generally considered ES3. Okay? When you get up around the 109 watts, it goes into the ES3 basket. So we're actually doing 2,000 watts, and it's still ES2 compliant. And that's because of intelligence of the system. Within 5 milliseconds, power if that packet of data is not received. So there's a number of fail safes built into the management system of the unit. Yep. So it actually sends a packet of data that has to be received by the receiver every 2 milliseconds. So if anything happens within 2 milliseconds, that system either going to Earth, shorted out in some way, it will actually shut the system down. So if somebody comes up and grabs the copper conductor, which when we demo this in our factory in DY, I actually do it every time. I go grab the copper conductor. There's 2,000 watts counting down it. The system shuts down. I'm still alive. Probably wouldn't do it if I had a pacemaker, just in case. Absolutely. I've always found that length and size do matter, mate. Hence my build. There is nothing small about it. So it is safe for humans to touch. Okay. This is the sort of, this gives you an overall schematic of what a system would look like. You have a power supply, you have the head end, you have a small twisted pair cable, you have a receiver, and then you have your remote device. So that could be an RRU, it could be a power over Ethernet switch, could be anything. The camera, security camera, whatever needs a power source. Safety compliance. This is a graph that shows you the measurements that we've done in our factory, how quickly the system reacts. Okay? And it shows you the amount of power, the fault lines, and it shows you how fast it actually reacts. May not mean a lot, but I've actually got all of this data in figure form rather than charts, so you can actually. Installation guidelines, as we said, it's ES2 compliant. We put a number of questions to the standards committees, both the Datacom and the electrical standards committees, and the responses back basically made the system itself fall into a number of different categories. But not once did, because of that human safety aspect, not once did we actually fall into the ES3 category. There are a couple of items that we tested at very low power frequencies that fell into ES1. Now, the main thing about having an ES2 compliance rating, first thing, zero separation from your network. You can actually put the VoltServer cable inside the same comms duct as your Cat say. Okay. Without having all the electromagnetic interference. So zero separation from power. And because it's safe, you don't need an electrical trade license. Datacom installers can install this system. It's simply a plug-in. Nobody's going to get hurt from it. You still need to have your comms provider license. You still got to have your provider license. Have some idea. But generally, it's made up of a couple of simple items. So a head end unit that we module into the line card modules into, and fix it up. So use AC power source. You can actually put a single head end unit can put out about 12 kilowatts, up to 2 kilometers. If you use a DC, it's a matter of how many cards you put into that rack unit. Head end will give you 5.4 kilowatt. A 3 rack unit head end, fully populated card, 8. And then you have things like the power supply, some pre-terminated cables, termination, and then outside over voltage protection units for outside plant installation. Then you have the receivers, so 48 volt DC, so 48 volt DC, 2,000 watts. Out. I want to go back to BICSI, the converter. Have a quick look at that. Case studies, but majoritively, a lot of the will run on the 40 volt piece. That put it all together. What is it? You have the head end, you have the receivers. What does it actually allow you to do? There's one of the cables, you've got capacitor, core, and the screen. They're two very key elements. But what does it allow you to do? As we said before, not PoE, it's a power device. So it can power up your PoE switches. PoE switches that can then power up Bluetooth gateways, Wi-Fi access points, management, ICT products. We also can power up emergency lighting. But we're moving further and further and deeper into the network. You have all the sensors, Wi-Fi or Bluetooth gateways that are run off power over Ethernet switches that are powered by VoltServer. Okay, and you don't have to worry about power over long distance. Okay, so it doesn't need to be powered on every floor. It can actually be powered from the VoltServer unit sitting in the sub basement with a receiver on the floor. Okay. We're doing a design at the moment for a customer in Sydney for a brand new commercial building. They want to go off grid. They can't take everything off grid. Obviously, you got air conditioning and things that require a lot more power than what VoltServer can deliver. But we can deliver all of the power requirements for a desktop. You're either using an IEC bank or a USB-C hub. Okay, so we can take a head end, put it into their data center room. We take a receiver and we can put it either above or underneath the desk of a cluster of workstations. And then we can have the cable coming out into a PoE switch, or we can have it coming out into an IEC outlet switch strip on the desktop, and you can plug your monitors, your charger for your phone, your charger for your laptop or your computer, all of that off the outlets. Okay, so you don't need to put a GPO on the desk anymore. USB-C charging. So again, you have your receiver close by the work cluster, and then from the receiver, you could take it out into the terminal block and into a USB-C hub charger. A lot of that stuff these days will actually plug into USB-C for voice over IP phones, laptops, all of that. You can charge off USB-C. So basically, the next step. So we've gone powering the building management systems. We've gone to power the DAS systems, the IVC systems. Now we're going into the desktop systems to deliver power to those guys. And you've got to remember, when you're inside a building, you don't need three pair 2.5 conductor size cable to run that amount of power anymore. You can start dropping the amount of copper conductor that you need, because you're only going shorter distances. Okay, so having a 2.5 to every desk, or maybe two 2.5s to every desk, is now redundant. And with the LED lighting applications and power over Ethernet, having a 1 mil run through the roof to power up lights is now redundant. Okay, what does that do? It's more sustainable, less copper, cheaper to deploy, all of that sort of stuff. how has it been used? And thanks to Kai, a bit of a pioneer in our industry, Australian first installation right here at Curtin Uni. Kai took a punt on the technology, saw the benefits, went ahead and put in a pilot program and ran the typical applications that you would initially think about off the VoltServer product. So we have lighting. The lighting system run off AC, not DC. So we had to convert the DC power that the VoltServer system delivered back to AC so they could run the lighting system. Okay. But then we also had all of the items that ran off the DC system. So we had, I think it was nine 48 volt loads go out to the yarning circle to run the PoE switch. It is a PoE switch, yeah? Yeah, but it's an Ethernet switch. We've got cameras and the intercom system being powered in the yarning circle. What was the distance there, Kai, between the head end and the yarning circle? To 300 meters. The cable has water sweatable yarn in, I think. Yeah, yep. So we can't use gel or anything like that. It's got too high moisture content for power. But yeah, we can use water sweatable and water blocking tapes. 1.5 mil conductor delivering all the power for all of that load over 300 meters. So it was 3 pair, 1.5 mil. 3 pair, I'm pretty sure it was a 3 pair, 1.5 mil cable. To take the next step, we put fiber in that cable and use the fiber to transfer the data in that hybrid cable so we could deliver the power to the devices and then use the fiber inside that power cable to deliver the data transfer. So we could really take that next step of combining the power and the fiber into a single cable unit to not only deliver power to the PoE device, but to deliver the backbone data from the PoE device back to the head end. Another case study in the US, Las Vegas, big casino, massive casino, 770 rooms. They deployed VoltServer across the casino, the Circa Resort, and they pretty much run everything off VoltServer for all the building management systems inside the hotel rooms. So the card readers for the doors, the blind openers, all of that runs off the VoltServer. Even the emergency lighting runs off the VoltServer. But that VoltServer is actually powered by a UPS, so they could collapse the entire UPS system in the building. No longer did they need a UPS every floor or every second floor. They brought it all back down into a single UPS unit that delivers the power to the VoltServer, and then the VoltServer delivers the power to the receivers on the floors. Atlanta Braves Stadium. This is really where VoltServer started life. It was actually to power devices around NFL stadiums. And it was really to power the comms. So we're talking about LTE, 4G, 5G antennas and things like that. And it worked so well, they took the next step and started powering TV screens, scoreboards, advertising hoardings, remote digital kiosks. You know, you go up, where's my nearest beer outlet, and just tap the screen and it tells you that sort of stuff. So they moved it further and further down into the network to the point where now they're running all of the Ethernet requirements on it, and they run all of the point of sale products. So the cash registers, the FPOS machines, all of that runs off the VoltServer now. installation in Sydney for Optus. They couldn't put a RRU into a rail tunnel. They didn't have the space to deliver the power cable, the size power cable that they needed. They didn't have the speed of access to haul that power cable because it was so big. So they put a two head end units in from each side, what we called Rex and Annie. Yeah, that's it. That's it. And they put in that central location, they put the receivers, and they power up the remote radio units to deliver their signal to their customers that are on the train inside the tunnel. So that's operational. It's been operational for 8 months now. Okay. And again, it's all run off batteries. It's all run off the battery bank. It depends on how many cards you've got in the head end. So you could split the power load across different receivers from the head end. So you might only have two of the cards, the transit, the cards in the head end going to a single receiver, or you might have all 8 where you need much greater power delivery. So it does take a little bit of design work to work out what your power load requirements. Yep. Yeah, it was when they worked it out, they had to use I think it was a 3-core earth orange circuit, and it was I'd have to check. I think they were talking about a 75 mil or something to deliver the power they needed over those distances. But I'll check it out. I do know what it was. It's a highly efficient system. The voltage drop. We're pumping a lot of watts down the cables, so the drops aren't significant. You got 48 DC in, 48 DC out. So, yeah, I do have some data on that I can share with you. As I said, I don't want to get too bogged down in the technical stuff, otherwise we'll be here or not. We haven't had any data on it yet. The product has been around for about 7 or 8 years in use, and we haven't had any failures as yet. So.
Transmitter increase the heat load.
Slightly, yeah, it does, but it actually has a dispersion plate at the back of the receiver to actually disperse the heat in the receiver. In the head end, okay, it produces about the same amount of heat as a normal switch, a normal PoE switch. Because that's about the limit that we can get. The efficiency of the power delivery after 2 kilometers drops way off. Installed in a couple of 5G networks in Melbourne and Brisbane. The thing about this is that when the telcos are delivering the 5G antennas, they need to get the local power authority to deliver power to those 5G antennas. And some of the connection costs within the CBDs of Australia are horrendous. Telstra had a quote in Melbourne to deliver power to 6 antennas. Now you can see we're actually We've got a lot more than 6 antennas connected to the VoltServer system. $110,000. $110,000 to deliver the localized power to 6 antennas, and we've got 7 hooked up over a much greater distance, 3.5 kilometers off a single head end. So widely used now, thanks to Kai's pioneering effort of putting it in here. It gave us that initial, I guess, case study to go to market and say, this works. You know, we have lots of them overseas, and you're going to see some of them later tonight. But from an Australian perspective, it really launched this product. And unfortunately, we'd probably be a lot further on if it wasn't for COVID, because we did this a couple of years ago. As Kai said, it's been in for 2 years, operating without missing a beat. We missed so much to capitalize on that because of COVID, unfortunately. But we've got this building in Sydney that we're doing the design for now that will take it that next step, because we're running the entire building off the VoltServer. All of they wanted to go off grid completely, and I've got an NDA, but so I can't tell you exactly who it is. But this company, the guy that owns it, is a climate change fanatic, and he actually wanted to buy a power company to shut down their coal-fired power station. So without naming who they are, that's the extent they're going. But VoltServer allows them now to take that building almost entirely off the grid, because they're going to power that entire building with solar panels and batteries. And it's only going to be made possible by VoltServer.
Any more questions?
I'll give you all that tech data, because it actually varies.
Yeah, we didn't actually start to give you the answer. I'll just have a question.
It actually varies the different type of receivers, whether you use an AC or DC and things like that. But yeah.
With like the companies that you've got to install it in places like Curtin and Pi, for instance, do they come back to get you to design more projects for them, or?
We haven't as yet from Curtin, but but certainly using it as a case study is how we got to the rest of those projects. And you can see it's quite a diverse list of projects, you know. It's in telecom, it's in commercial building, it's in rail corridors and things like that. So. But as I said, there's a lot of tech data. It's a very technical product. It's a very smart product, you know. So we could get bogged down quite easily in all the tech stuff, but yeah. NBN were paying, I think it was $6,000 a node to get local power delivered to the nodes on average across the country. We haven't had any real issues there. There's been a number of sites that have gone on to diesel generator power and things like that. As I said, it doesn't matter whether it's AC or DC input. It works. Yeah.
All right.
Thank you, everyone.
That's good. No, that's it. Done. Cut off. Thanks.